Hi, and welcome to a problem where we will integrate the teardrop problem for Calculus 2. So for example, let me show you what the teardrop problem looks like. So if I graph the given teardrop problem that we're dealing with and I look 0 to 2 pi, here's what I see. And so what we have found, and I'll integrate this one way, but certainly there are other setups involved, but I'll just show you one setup through its integration. And we said that we could integrate this right half. So if I change my window to just be negative pi over 2 to pi over 2, then what I can see is I get the right half of this teardrop. And if I look at a horizontally laid rectangle to add up all my infinite areas of the rectangles using my Riemann sum, I am stacking them from the bottom to the top, and I can see that it's an easy kind of right minus left, where the right is always the teardrop edge and the left is always that y-axis. So we're going to set this up using the x dy format, meaning my distance going across is the x, and the width or thickness or depth of each rectangle is that dy. And then when we're done, we're going to absolutely have to double this area because remember my teardrop was the whole teardrop, not just half of it. So I'm going to take that x dy setup that we have and we're going to actually have to make sure that we double it. Now, I'm going to double at the end. You can certainly put that double in. Well, let's just keep it in because I don't want to forget it. So let's just keep that 2 in there because again, I don't want to forget it at the very, very end. So the first thing that I'm going to do is I'm going to distribute. And so this 8 cosine of t is going to get distributed into each term. And so I have 64 cosine squared t minus 8 times 4, 32 sine 2t cosine t dt. I'm going to look at this as two completely separate integrals because my method or technique for integration is going to be different in both. So I'm going to look at this first integral and then I'll separate and do the second integral. So in the first integral setup, I'm actually going to have 128. If I pull that 64 out front, my bounds are still negative pi over 2 to pi over 2. And I'm integrating cosine squared t with respect to t. So for that, I'm going to be able to use my reduction formula or that double angle from the cosine 2t. So the second one, I still have this 2 that has to be applied. So I'm going to say minus 2 times 32 would be 64. And I'm integrating sine 2t cosine t dt. And I hope we can recognize the technique of integration for that one because sine of 2t is the same thing, my trig identity, putting my angles the same, would be sine 2 sine t cosine t times that initial cosine t that I had. So the rewrite of that second integral would look something like 64 times 2 is 128, and I have sine t cosine squared t dt. And my bounds have stayed the same, negative pi over 2 to pi over 2. Okay, so if I do my rewrite on the first one, we said that that rewrites to 1/2 1 plus cosine of 2t. So I'm going to kind of have an intermediate step here. I'll move this 1/2 out front. So I have 64 now. It's important you keep your coefficients known throughout. Like, did you move something out front or did you not? Because coefficients are definitely easy to screw up. So negative pi over 2 to pi over 2. I now have a 64 out front and I'm integrating 1 plus cosine of 2t with respect to t. So I think I'm ready to just integrate now. I do have two completely separate integrals and two separate techniques of integration. So I'm ready to integrate the first one. I get 64 is on the outside. I have a t plus sine 2t over 2 because the antiderivative of cosine 2t would be sine 2t over 2. And I was going negative pi over 2 to pi over 2. Okay, if I wanted to finish this integral out, this first piece of this problem here, I'm going to substitute in the pi over 2. So I have pi over 2 plus sine of 2 pi over 2 would be sine of pi, which is 0. And I'll substitute in my lower bound or lower limit of negative pi over 2. So that would be t, negative pi over 2. And then same thing, kind of, I have sine of negative pi once I substitute that in that second term, which gives me 0. And so I have pi over 2 actually plus pi over 2, which will give me 64 pi. Okay, now let's work on that second integral. Well, this integral, sine t cosine squared t, is just traditional u substitution. Can you see it? So if u is cosine of t, du is negative sine t dt. So if I throw that negative in, I can throw the negative out, which means I'm going to be adding this area, no longer subtracting it. And now what I actually have is plus 128. I'll put my bounds in a second, and I have u squared du. Okay, that wasn't too bad because I can integrate u squared all day long. But here's the tricky piece of this. If you go through and change your bounds, like we always do, right? If t equals negative pi over 2, u is, well, u was cosine of that. So cosine of negative pi over 2. Do you recognize cosine of negative pi over 2? That's down here. Cosine of that is 0. Okay, no problem. If t is pi over 2, u is cosine of pi over 2. Well, same issue. Cosine of pi over 2, now we're up here, is 0. So technically, I have an integral that goes from 0 to 0. If we have an integral that goes from 0 to 0, and I'm trying to find the area under any of those curves with respect to whatever, it's 0. But let's prove it to ourselves. Let's just integrate this, keep it indefinite here for a second. This becomes u cubed over 3. And let me put back in what u was, so you can see why it turns out to be 0. U was cosine of t. Okay? And now I can say we were going from negative pi over 2 to pi over 2. And if you wanted to put bounds on the previous steps, what you would say is t equals pi over 2, because it's not the same variable, so you would want to make sure you know. And t equals negative pi over 2. Same thing here. I could say I'm integrating from t equals negative pi over 2 to t equals pi over 2. All right, so now I'll put in, so again, I've got the 64 pi already, and then I'm going to add in 128. Well, cosine of pi over 2 is 0, right? And I'll subtract 0. So this whole thing adds to 0. So my total area should be 64 pi. I hope you found this video integrating this teardrop problem helpful. Again, there's a separate video on the teardrop setup as to why it is the way it is. Thanks for watching.